If you own a home theater system, you've probably spent thousands of dollars on your equipment.
Once you've spent that much, you're most likely going to spend a little bit more and buy some high-end monster cables like these.
So today, we're going to explain everything you need to know about the Monster Hype and how to build it yourself at a fraction of the cost.
I'm Kevin Rose.
I'm Dan Heward. Welcome to Systm.
So as you can see, this is not Dan Heward. He's actually out buying more of these high-end audio video cables. But this is David Randolph, who's a broadcast engineer. He's been doing this a little over 12 years now. You have a ton of experience doing this.
Oh yeah, about 5 years ago, I stopped counting at 500 miles of cable.
That's a lot of cable, but that's why we need you, because we're talking about high-end cables today. And I just went out and went down to Best Buy, bought these two cables, and $120 for two monster cables. It seems a little pricey. Is there a way that we can actually build these to spec for less money?
Absolutely. I mean, you're looking at just what you need to hook up just a DVD player to a TV. I can outfit your entire entertainment center and everything in it for less than the cost of that alone.
Perfect. Sounds good to me, but I want to go through some of this stuff because I know when consumers go and they pick up these packages and they flip them over, there's a lot of different marketing terms on here. Some of it seems like a little bit of marketing hype to me, but let's talk about each one of these terms and then you can tell me what you're going to create to kind of match that. So starting off here, first thing, 24 karat gold connectors. Now gold, obviously, I hear it's like the best metal. Everybody uses it. Why are we using it here and is it necessary?
Well, yeah, gold is by far the best conductor of electricity. I mean, that's why NASA uses it on everything. But at the end of the day, you have a copper cable through tin solder to a gold connector.
Right. And
it's really the weakest link in the chain is your tin. So having gold, you gain nothing because it's just like having tin all the way through the whole thing.
I see. So if they're going to gold, I mean, I see gold-plated USB connectors. I mean, that doesn't make sense to me. It's like a digital connection. Why do you need that? It's more marketing than anything else.
It's more marketing. It looks real pretty, and you get to tell all your friends, I've got gold.
Right. So, okay, next one here, the split tip center pin. What's that all about? I noticed that each one of these pins on the outside actually has a split right down the center.
Well, that's one thing that Monster does that's really great. It's a patented technology by them, and what they've done is they've made the end of the connector so that it spreads apart and pushes against the outside of the actual connector.
So they get a good connection every time you push it in.
Excellent. We can do the same thing with a pair of needle nose pliers and just pinch in the end a little bit to give it an oval shape so that when you put it in, it squeezes back around.
I see. So we can get right around that patent with some needle nose pliers itself. Okay, now how about silver solder? So they've switched solder on you here and they've gone silver, but they're going copper, silver, gold now, right?
Mm-hmm. So, I mean, the best metal in that is, of course, going to be the silver now. Mm-hmm. So they do a little bit better, but we're going to make up for it with a better quality cable. We're going to make up for it with better cable links and better connectors in general.
Nice. Sounds good. Now, this one here, double shielding, 100% foil, 90% copper. So this is 2 levels of shielding on the cable, correct?
Correct. What they basically have is they have a solid shield around it, which is good for generally stopping any interference around it. Mm-hmm. Then they have braided shielding on the outside of that. This braided shielding is calibrated for about 75 ohms, which is what's going to affect them. And they put that, they hope to capture all that, and then anything else that falls over, they hope to capture by the foil.
Okay.
Our cables use the same thing. The only difference is that our shielding on the braided side is just a little calibrated, just a little bit closer to 60 hertz, 60 ohms rather than 75 ohms. Mm-hmm. So we get a little more coverage on the outside than they do on the inside.
I see.
And it's all about stopping it at the first chance you get.
Excellent. All right, so this one here always confused me. Patented gas-injected dielectric. Now, what is this gas-injected? What is that all about?
Well, basically, the first thing, the dielectric is the foam that separates the center conductor from the shielding on the outside.
Okay, so is that, let me get this straight, so you have the copper in the center, and that's right on the outside, kind of like that little filling that you see around the outside, is that what that is?
Right, that little white stuff you see. And they use this really great, it's very uniformed, all that. We're using gas injected, but it's not done the same way. So it's very close. But when Monster Cable goes to test all their cables, they're testing their specs against the cable we're using today.
Oh, nice.
And ours is the key reference. Everyone builds their equipment around it. So rather than try to make something else, we're going to make it identical to what all the professionals are using.
So, so when you say professionals, I mean this is what you would use. The cable, the bulk cable that we're buying, is what you would use in a production facility. Like this is standard broadcast quality cable.
Yeah, any professional environment, any long runs, any environments with lots of interference, we're going to use the same cable.
Excellent. Okay, now the last thing here: high purity, fine stranded copper conductors. So what are they referring to here? I mean, that's just the center conductor, right?
That's the center conductor, and if an audio cables, it's the stranded center conductors, and that's just the quality of the copper. And at the end of the day, there's some impurities in copper and what have you, and there's always going to be a level. It's a very good marketing term because they don't actually tell you how pure it is. They just tell you it's high purity.
I see. Okay, so there's a little bit of marketing there.
It's a little bit of marketing, and our cables have high purity as well.
Okay. And then the last thing here is there anything that we can do with these cables that go above and beyond kind of what Monster is doing?
Absolutely. I mean, the number one problem with Monster cable is that when you buy them in 4-foot, 8-foot, 12-foot, 25-foot lengths.
I can never get the right foot. I always have like a mess of cables in the back that are just totally wound up, and I don't know what to do with them. So
those windings that you have back there are creating huge antennas for interference. That's the number one problem back there.
So no winding.
No winding. There's no winding, no coiling, no bunching it up, no letting it drape and cross other cables. Your key thing is to get the signal from your device to the other device as fast and straight a path as you possibly can.
So you're talking about going out and then actually measuring exactly the distances that you need and then cutting to spec the precise distances so you don't have to have any of that extra looping or anything else.
Exactly. You're going to end up with a 1 foot 6 inches of cabling that goes between the two. You'll never find that cable in any store you go to.
Okay, so tell me overall, a lot of people probably wonder, what do broadcast engineers think of Monster cable? I mean, is this a high quality cable, or do you always go with making your own, or in a pinch do you use this? I mean, what are you doing? I mean, obviously at home you're creating your own stuff.
Right.
But I mean, as far as the quality is concerned, what do you think?
You'll never find, I mean, they're great. I mean, you'll never find us in a production environment because no one in their right mind would spend that much money in a professional
It's the price, really.
It's the price.
Okay.
If I had a person that really had no electronic skill and couldn't wield a soldering iron, I just didn't want to deal with them, I would send them out and buy Monster cables.
Okay.
But if there was a person I was willing to spend about an hour, 2 hours around, I would definitely teach them how to solder and make their own cables.
Nice. Well, let's pull out the tools and let's make some cables.
Sounds like a plan.
All right, so we're ready to make our first video cable. We have the cable itself, we have all the connectors, and we also have the tools that we're going to be using. So I guess we can start off by describing all the tools.
Right. The first tool we're using is a coaxial stripper. In this case, we're using a generic one, but that's because my new Paladins didn't come in. That's my personal favorite, and that feels really good. The next tool we're using here is a set of crimpers. In this case, I really like the Canary crimpers. Paladin also makes a good set for you. And then we just have some standard diagonal cutters. Got a small size and a medium size. Use a small size for trimming up the little extraneous wires, and a medium size for getting straight through the cable.
Okay.
Then we have the connectors. We're using C53 Canary connectors.
Okay, so I imagine there's just a ton of different connectors out there. How did you land on these?
Well, I really like Belden cable and I really like Canary connectors, and when you start kind of cross-checking them all, these Canary connectors work with this Belden cable. Okay. That's one of the problems you have out there, is because there is 1,000 different types of cables, there's 1,000 different types of connectors. You've got to match one with the other. So if you're shopping and you want to, vary from this list, you're going to have to do some homework and really think it out.
And these are gold-plated too.
And these are gold-plated, so they're going to look pretty, and you'll never see them again.
Nice.
Now, parts of this actual Canary connector is that you have a center pin, and then you have a sleeve. Now, the center pin is what actually slides up through the middle of the connector and makes that connection for the center pin. And the sleeve is what actually grasps the cable and squeezes it around and holds the cable together, holds the ground to the outside of the connector, and finishes off the whole thing and makes it look really pretty.
All right, and then what about the cable here?
Well, this is Belden 1694A cable. This is kind of my favorite. This is used in a lot of broadcast operations. And when they use it, they're using it for serial digital transmission, which they use for very long links. We're talking 500 plus feet per cable. And I figured if it's good enough for serial digital broadcast, it's good enough for our little, home entertainment center.
All right, and then I guess we have some shrink tube to finish it up.
Exactly. We have to have a red, green, and blue, because if we're going to make a component cable, we want to know which ones are red, which ones are green, which ones are blue.
Great. Well, we got everything. Let's make our first cable. All right, so you got to be seated when you create these things, right?
That or you're going to tear up your back.
All right, so you got a nice seat here. We've cut some cable. What are we doing? We're making a 6-foot cable to start with?
Just a good, simple 6-foot cable, nice and easy.
Okay, so I guess we're going to start off by stripping the cable, right?
Right. So we're going to use this coaxial stripper here. And one of the key things you're going to notice is that when you first get your coax stripper, it has to be set up for that particular cable type.
Okay.
And if you look on the back side of any coax stripper, they usually include the little Allen wrench to do all the adjustments with.
That's nice.
Even on the cheapos, they have that. So what you'll notice is there's these little gauges here, these little adjustment screws. And what that does is that inside the connector there are 2 blades. This adjusts the depth.
I see.
The first blade is specifically to cut all the way through everything and just expose just the center conductor.
Okay, so it gets right down to the copper.
Right, that's center copper.
All right.
The second blade is just a little bit further back, and that's just going to remove the insulation so we expose the shielding.
Okay, so it gets rid of the plastic sheath that's going around the outside.
Exactly. So we've already adjusted this one, so let's go ahead and just strip this cable here and get it ready to go.
Okay.
So I'm just going to put this all back together. And there's always an outside and an inside. And the outside is where you're going to have to put your cable through. And when I'm making RCAs, I like to leave just a little bit extra, and I'll trim this off later.
Gotcha. It makes it easier just to trim the outside.
Right. You can always cut it off. You can't add more. So then you spin it. I usually like 3 or 4. You'll feel the blade cut through. When you get all the way through, give it 1 full rotation back.
Okay.
What this does is it does the final cut and really helps clean the cut up. Now, the most common mistake that most people make is that they just yank it off to make it all nice and pretty.
I was just going to do probably the exact same thing.
And that just dulls the blades.
Okay.
And if you pay 30, 40 bucks for this tool, you want it to last a while. So you pick it up and open it and then kind of drag it off.
All right.
And what you're going to do is first take the cable, twist it, and pull it off. And there's our center conductor.
Wow, that's nice and clean too.
Nice and clean. There's no little nicks on that or anything.
Okay, so that was the first cut. Now there's a second cut a little bit further back, right?
Right, there's a little second cut right there. And it's a little harder to get off. So I usually grab the big dikes here, and I'll just kind of pinch it a little bit and wiggle it.
So you just want to take off that outside casing, right? There
Right.
It goes.
And you don't want to pinch so much that you actually touch the shielding.
Gotcha.
Because you want to leave as much of that intact as possible.
Okay.
And that's my general rule of thumb.
Perfect.
The next thing is we need to trim the center conductor to exact length.
Now, what is exact length there? How long do you want it to come off of the end here?
It completely depends on the connector you're working with. My general suggestion is I tell people, figure it out. It's probably the easiest way. And if you go and look at their websites, they have drawings and you can try and measure it. But my little trick is I take the connector and I lay it up against the wire, and it's going to be pushed down, and this little collar here is going to slide just slightly underneath of that. And if you look at the connector, you can start to see where the center pin is going to be. And the last time I measured it, it's right about at this little tick mark.
Okay.
Good rough guesstimate's 1/2 inch, something like that. You can start and push it in and find out what works best for you.
Now, how will you know if you cut it too short or too long? How can you tell that out?
Well, once we push the center pin in, you won't hear it click.
Okay, so
if
you're
it's
looking
too
for that
short.
snap, that center pin to snap into place.
Exactly. If it's
right.
too long, this won't slide all the way down. You won't get enough of that shielding around it.
Gotcha.
So that's kind of your hit and miss. And after you kind of figure out the system for that connector, then you're good to go.
And there's no going back and doing this again, though, right? Because the connector is completely sealed.
That connector is completely sealed. There's no backing up. It's like I like to tell people, after you start the project, your first time you're going to probably lose 1 or 2 connectors just getting everything prepped and ready to go.
Right.
Which isn't a big deal. It's a couple bucks.
Yeah.
Considering how much you save, it's worth it.
All right.
So I've got my measurement, and it's just about right where I want it. It should be good enough. You have a good margin of error, about 1/8 of an inch either way, so you have enough to work with.
Okay.
So the next thing we have to do is put one of these center pins on. These center pins are really small, and I can't tell you how many of these I've lost in the carpet. So if you can, don't do it over carpet because you'll lose them and step on them in the middle of the night and you'll say a lot of bad things.
All right.
And you notice you just slide it over the center, push it down as far as it'll go, and you pick up your crimpers. Now, on a crimper, you'll notice that on the back side, there's a small little hole. Kind of looks like a mistake.
I see that.
No, this is actually for crimping the center pin.
Okay.
And what you're going to do is you open the crimper and you lay the center pin in all the way and push it up to that little sleeve. And then you start pinching down. and then squeeze it all the way shut.
All right, so that's crimped down. You can't really pull that. It's a good snug connection. Yeah,
It's a
good.
very snug connection. You can pull on it pretty good, and it's not going to come apart.
Okay.
So you have this crimp, and then you're going to have this outer crimp to really solidify this connector.
So what that center pin has really done is it's added a groove right there so that you can slide it in this connector and get that good solid connection.
Right, you're going to hear a little click, you're going to feel a little click.
Kind of locks it in place.
Just locks it in place.
Okay.
And that's where you know you have a good connection. Now, the next thing you have to do is we have to kind of make room, because as we shove this down, we want this shielding to get as much around the outside as possible.
Okay.
So what we have to do is just kind of peel back the shielding. Now, we're peeling back the braided shielding, not the foil shielding, because we're going to have the foil shielding go inside the connector and the braiding shielding coming around the outside of the connector.
Gotcha.
Just to make a really good connection. More metal on metal is always the best thing when it comes to connectors. Now, I've already forgotten one important step here.
What's that?
Which is really important, the sleeve.
Ah.
If you don't put this sleeve on and you put that connector on, you've ruined the connector and you got to start over.
Okay.
So remember, put the sleeve on. Sometimes you need to do it before you actually peel that back. It's
I was going to say, you
easier.
could do this before anything else though, right?
Exactly. But if you forget, just push it on there and call it okay.
Okay.
Make sure you remember that, especially on the second connector, because you can't cheat it back the other way. So after we've done that, we can literally slide it on. And what you're going to notice is that you're going to get a little click out of it. And it's going to take a little bit of force to kind of get it right in there. And you're going to feel it click, and there we go. Now it's in there.
All right.
And it's on there pretty good. So we got it just about right. Now we want to just fold that shielding back over and kind of make it as even as we can with our fingers.
Right.
And just kind of push it up there and get that collar as close to the insulation on the outside as possible.
Okay.
Then we're going to literally take that sleeve, slide it over, and it's already starting to look like a connector here. So we're going to take our final crimp here, and you're going to notice that your crimp always has a side with the screw and without the screw. When you're doing the final crimp, you do the side without the screw towards the connector.
How does that differ from doing it the other way?
Well, that screw will hit the connector and not make it crimp all the way up.
Okay.
It's just a mechanical flaw in all crimpers, so you just got to remember to do it that way. And you just literally just slide it up, and you just sit there and crimp. Takes a little bit of force.
There it goes.
Now, you're going to have to do usually 2 crimps depending on the length of the collar, because you get this little bulge at the end. And I like to make mine pretty. And what I do is I literally lay it in, make sure I get the exact same angle that I had before, and crimp again. That way it kind of makes it nice and pretty and clean. Now you have a really strong connector. It's rated for up to 25 pounds of force before it'll pull off, and it's ready to go.
Okay, so now I guess we have to finish it up with a little shrink tubing, right?
Right. What we're going to do is that if we're going to make a component cable, we're going to assume that this is your red, green, and blue cable, and let's go ahead and say we're doing the green.
All right.
You literally just sit there, and you're going to take, and I'm going to cut off about 1 inch to me. This is just an identifier. Now, unfortunately, this time I forgot to put it on. It always happens. So just remember to slide it over the other end if it's still open. Work it all the way down the cable to the other side. That's the benefit of remembering the first connector, but don't forget on the second pass.
So what about the size of this shrink tubing? What are you looking for here? I mean, I've seen it varies. You can get extremely large size shrink tube, but then how far can it actually shrink down?
Well, most shrink tubing is actually printed on the package, but most of it out there shrinks to 50% its original size.
Okay.
So if
good.
you get a 1/2 inch, it's going to go to 1/4 inch, yada yada yada. You do the math, and that'll be it.
Okay.
I like to get as close as possible because that way you don't have to shrink it as much, and it'll stay stronger. Because the more you shrink it, the more fragile it becomes, the more rubbery it becomes. So the closer you can get, the better off you are.
All right.
Now, when you're shrinking this stuff, you either use a heat gun, which is a really expensive trick, or you do kind of my little rogue way and just use a lighter.
Okay.
Just gently heat it up and call it done.
All right.
And that's it. And that's your video cable. Now, you could use this cable for component video or composite video. If you're going to use it for components, you just got to make it 3 times.
I see. Now, what are they? Now, obviously, when you use it for a component, you can actually use it for HD as well.
Exactly. It's fully
Is this
up to
rated?
spec.
Oh, it is up to spec.
It's fully up to spec for a component HD.
All right. Sounds good. Well, let's make an audio cable.
Sounds good.
All right, we've added a few new tools. We have the multimeter, the soldering iron, and the solder sucker, and then we've also added some RCA connectors and some audio cable. What type of connectors do we go with?
Well, we went with Canary. We used the F09s. The F10s work just as well if you can get your hands on those. They just have a different crimping system. My personal preference is the F09s in that case.
Now, how about the cable itself? I noticed that this is a lot thinner. Normally when you're looking at typical audio cable or speaker wire, it's so much thicker than this. Why so thin?
Well, when you're looking at speaker wire, you got to think of it as you're dealing with higher voltage that you're sending down the cable. You need to have less resistance for higher voltage. But when you start dealing with low voltages like audio cables, analog cables specifically, if you have too much copper there, the signal kind of gets more noise and interference in it, and it can actually cause some resistance in the cable.
Oh, interesting.
So when professionals use this, I mean, they use this, they put it in huge bundles and run it up racks and hundreds of feet. And if it's good enough for them, it's good enough for us for our short little 2 and 3 foot applications.
Right, and we should say this is just between component to component. We're not talking about actually ever running any of this out to speakers or anything like that.
Absolutely not. You'll be extremely disappointed if you did.
All right, so let's go ahead and create one of these. All
right. Well, the first thing we have to do is remove this outer sheathing. Now, I know I talked about earlier about not using a knife or a blade or anything like that, but to be honest with you, I do. I cheat here. One of the key things to think about is that the stripper for this, if you want, it's about 40, 50 bucks. I say, waste a couple of feet and learn this skill.
Right.
And what you do is you basically take your utility knife and you lay it, face, with the blade facing up, and you lay the cable on it, and you very carefully.
Yeah, I was going to say, you're not putting your finger over that blade right now, are you?
I'm putting it over the blade, but very carefully do it down. And just pushing a little bit of pressure on it, and just rolling the cable over it, just a little bit. Very carefully. Remove your thumb. You will cut yourself the first couple of times. Trust me.
Yeah, Systm recommends actually getting a stripper and doing it the right way. And we don't recommend this, but this is a way, if you don't have it laying around, that you can do it.
Right, if you're stuck.
Okay.
Now, sometimes, when you do it the thumb way, you just don't quite cut all the way through. So you just kind of come back and you just push it in and finish the cut, and there you go.
All right, so you pulled that off. What are you exposing now?
Well, what I've exposed is that this has 3 wires and then a foil around it. And we're going to basically just pull off that foil. We don't need it for this part. That foil is the first part of insulation for this whole thing. All of the wire runs through that foil.
Okay.
All 3 wires in here. But an RCA only has 2 pins. That 3rd wire is really for those high-end professional guys. They use a big connector, usually like a huge 1/4 inch or an XLR. We don't use any of those. All home devices are all RCA.
Gotcha.
So the first thing we have to do is take off one of the wires.
Okay.
And you would think, well, why not have the one with the little sheathing on the outside and then not cut and then cut off this one without it?
Right.
Well, at the end of the day, the sheathing is really not causing any insulation. It's just preventing shorts. And the problem is that if I cut this off and leave this exposed, I have this potential amount of metal here that's going to short off against, either the ground or something else in there.
Gotcha.
And that's going to cause me more interference.
Okay.
So what I do is I sit there and I go as far up the cable as I can, and I cut out as much of that black as possible.
All right, so you snip that off.
And that's just basically so it just exposes the red wire and the ground.
Okay.
In this case. Now, the next thing we have to do is take our connector, and they'll ship them to you, fully assembled. And you just kind of twist them apart. If you can't twist it out, you just grab a pair of needle nose, pinch it on, and it'll pull apart just fine for you.
Okay.
Now, this mistake, and I said this on video, and I'll say it again, if you forget to put this on and after you solder everything on, you will say so many curse words and swear so much that you won't know what you're doing with yourself.
So that goes on first.
Have to put that on first.
All right.
If you don't, you're really screwed. The next thing we have to do is, start to prep the links of these wires because they're very rough links. And what you do is basically take the connector and you can kind of measure it up by eye. And what you're going for is that you want to have all this white go below this outside collar because that's what we're going to crimp to hold this together.
Gotcha.
Your first impression would be to cut that red exactly the length and put it in there. We want it a little bit longer because we're going to put a bend in that wire.
Give it a little play then?
Give it a little play. That way I can tug on this cable a little bit. It's a little more forgiving, all those different issues. So what I do is kind of lay it in there, and I see that it's coming all the way down, and right about there should be good. So I'm going to kind of put my finger there, and I'm going to cut that off.
All right.
And it just goes flying across the room. But hey, it works.
Yeah.
What we're going to do here is we're going to kind of, dry fit it again and realize that, I'm going to have about that much bend in it when we're done. That's pretty good. We can work with that. That's within reason right there.
Okay.
One of the things you're going to notice is that we're going to solder that in first, and then we're going to solder this around the outside.
Okay.
Before we solder this in, we're going to have to strip off the end.
Gotcha.
And I have these cheapo strippers here. They spring, but you know, hey, they're $4, they work. We're just going to clip off just a little bit of that tip.
So you have a little bit of exposed wire there.
Not very much. I'd probably say a little more than 1/8 of an inch.
Okay.
And we're going to twist it really tight as we can. Give us a nice, clean twist on that.
All right.
And the next thing we're going to do is we're going to tin it. Well, I don't use a third hand. I use this huge clamp. This clamp is a little overkill for a lot of people, but for me, doing it all day long, it was an investment for me. $100, definitely worth it.
So now, explain to me what tinning does exactly, though. So why tin the end of the cable?
Well, if you're going to tin the end of the cable, basically what you're doing is you're just kind of letting the solder suck up into all those empty grooves, and it's going to create a nice solid center to push into the rest of the solder.
Gotcha. Fills up all the empty spaces there then.
Exactly. Makes it more into a solid core,
all right,
which is definitely worth it. And what we're going to do is we're going to take this clamp here, adjust it out, and I'm going to sit over here and I'm going to just kind of clamp it in just to kind of help out.
All right.
And we'll pinch that down. If you're pinching on a cable, don't pinch it so tight that it breaks the connection, because that's going to cause you a lot of issues.
Right, just snug enough to hold it in place.
Just snug enough to hold it in place, because we're just taking a little bit of solder and we're just touching the tip of it.
All right.
And what we're going to do here is we're going to take our soldering iron, take our solder, and we're basically going to kind of heat the wire and put the solder to the top of it. One of my favorite little tricks to do is I just kind of touch the solder just a little bit, and it'll heat the wire up just a little bit faster. And it doesn't take much, as you can tell. I mean, it's just a little itsy bitsy bit.
Perfect.
And there you go. It's tinned just beautifully.
All right.
And now what we're going to do is we're going to go ahead and put our little ends in, and we're going to solder that center pin in.
Okay.
But before I do that, I always like to take my ground wire and really twist it really tight. Just helps me with management later on. So now the next thing is that to put this into the clamp and do the work on it.
All right.
A lot of people say, you know what, you should clamp from the outside. Some say you should clamp from the center pin. My rule of thumb is that you should always clamp around the threads. The reason for that is that if you clamp on the center pin, you're going to put additional pressure on it you don't want to.
Right.
Clamp around the outside, you're going to put bad pressure on it. If you clamp near the collar, you can actually shift the center pin on it. If you clamp up here, it's usually the best area. It strips the threads just a little bit, but not enough to matter.
Okay.
So what we're going to do is kind of clamp that in just a little bit. Third hands work okay. If you're using one of those little cheapo third hands, it's best to actually clamp it onto the center pin and then put another clamp up here on the top, because you're never going to get a tight enough connection with just one little gator clip.
Right. Okay.
So the next thing we're going to have to do is we're going to have to drop some solder into that center hole.
How in the world are you going to do that?
Oh, very carefully. Basically, we're going to sit there and we're just going to kind of hold our soldering iron to the very edge of the hole, and just kind of, you know, warm a little solder, drop it in the hole.
That doesn't look too hard.
Warm a little solder, drop it in the hole. It's probably the easiest soldering you'll ever do.
You just hold it there and kind of tell it melts down and falls in?
Right.
Okay.
Your goal is to really fill up the hole.
All right.
Let me get a little more solder in there. You can never have too much solder.
Now all the solder is going to dry though, right? And then how are you going to actually push that down inside?
We're going to reheat the solder.
I see.
So it becomes kind of this little pool of solder to work from.
Okay.
And there, that's pretty full.
Yeah, it's all filled up.
So now what we're going to do is we're going to heat the solder and then just shove this all the way in.
Gotcha.
And that's going to make really the best connection.
Okay.
And I'm just going to kind of feed all this around, feed it all in, pull that back. And what we're going to do is we're just going to reheat that solder pool there. And it gets hot, it goes all the way to the bottom, and we're just going to push that all the way down. And I'm just going to clean that up. One of the best ways to clean up is to push in and pull up, and that'll just kind of bring all the solder up and make it nice and pretty.
Nice.
If you hold it there for a second, it'll become nice and solid.
Okay.
All right.
Perfect.
So now the next thing we have to do is deal with the ground.
Right.
I always take it out of the clamp when I'm dealing with the ground here. And what I'll do is that on the back side of every RCA connector, you're going to notice a little hole on there. That little hole is perfect for running the grounding wire through it. So what we're going to do is we're going to push that grounding wire directly through that hole.
Okay. Pull that all the way through.
Pull that all the way through there. And then we're going to wrap it around just like that. So we're wrapping it around the connector. And that's not really what we're doing for the connection reasons. It's to hold it in place while we solder it.
Gotcha.
One of the great little tricks. And what we'll do is we'll lay this back in the clamp. Now you're going to notice that there's all this dirty wire over here. That doesn't matter. We're cutting that off here in a second.
Right. So you're just focusing on right outside of the hole right here.
Exactly.
Okay.
In fact, kind of our goal is to fill that hole up as much as humanly possible.
Okay.
So what we're going to do is we'll kind of hold next to the metal here, and we want the solder to suck in to that wire.
All right.
So we'll get that sucking into the wire there. And we'll add just a little bit more. I always like to add a little bit. There we go. And it makes this nice little smooth pattern on the outside.
Perfect.
All right.
So now we have to strip off the excess, right?
Now we have to cut off the excess. And what we'll do is basically take the wire, pull it back around, and then take our little snips here and really cut it all the way off. Trim it nice and pretty.
All right.
And now we got all that working on it. And what we have to do is kind of force this cable down and put that bend in that cable we talked about. So now what we have is we have this really nice big bend in there. That's going to be our strain relief for everything.
All right.
Now what you're going to notice is you need to crimp this down, of course. And the best way to do that is to push the actual center pin. Give me a second here as we kind of work it around. And we push that underneath. And then after it goes underneath, we can kind of crimp it a little bit closer like that. Crimp it down, crimp it close. Seems like a bit of work, but the crimper for that is really expensive. And
something you can do yourself with needle nose pliers, right?
I don't know any real professional that actually does own that crimper, to be honest with you.
Yeah, it's just easiest to do it that way.
Exactly. And that's it. I mean, that's all there is to an RCA connector.
And when you crimp it that tight, I mean, you're just trying to get a good solid connection around the cable to make sure it doesn't move, right?
Right. So if some jerk comes in there and pulls on your cable when they should be pulling on the connector,
pop out. Okay. So now you slide everything up, right?
We slide everything up on it, and then screw it all down. Now, what I like to do, and this is kind of me, is after I do put it together, I will take it and twist it just a little bit, kind of locks it in place, makes it so it'll last a little bit longer.
Okay.
And then let's not forget, we just give a nice little pinch to the end there.
That's going to flatten it out a little bit so you get that good connection when you're sliding it in?
Exactly.
Okay.
Just a nice little subtle pinch on it.
All right.
And that's the audio connector.
So how do we test something like this?
Well, we have to finish up the other end, and then we'll have to do a continuity test on it.
All right, let's do that now. All right, the cable's complete. We got our multimeter. What are we testing for now?
Well, we're going to check continuity. The big reason to do this is to make sure, one, we don't have any shorts, and two, that everything we soldered is actually going where it's supposed to go.
All right, how do we go about doing this?
Well, the first thing we're going to have to do is we're going to turn on our multimeter and set it to its continuity setting.
Okay.
There's a beautiful little icon of a little speaker, and that's a universal symbol. And I always like to start off by just touching them together, and you hear a nice little beep coming out of the meter. That's when you know you have a good connection.
Okay.
And what we're going to do is we're basically going to test for a short first.
All right.
The way to test for a short, and actually what I'm going to have you do is I'm going to have you hold this connector right there for me. And what we're going to do to test for a short is we're going to touch the outside sleeve and the center pin.
No beep is good.
No beep is good. If it beeped, then we did something wrong. We got to pull them apart and figure out exactly what we did. The next thing we have to do is to make sure we have connections on both ends. So I'm going to use you as a little human clamp here, and you hold it in both hands. What we're going to do is we're going to test to the outside shield and to the outside shield. Perfect tone.
Okay.
The next thing we have to do is test the center pin to the center pin, and we have perfect tone. So we made this cable right. This is ready to go.
All right, excellent. Now, what about some other cables that we didn't get to cover today, say SVHS cable?
Well, SVHS is kind of a consumer term. In the professional world, we consider it YC.
Okay.
They're interchangeable. It's just kind of two different ways to say the same thing. And, you know, that's a 4-pin connector. It's really good for the video. The problem is when you're making those cables, they're just really hard to make. They're really annoying. They're 4 times harder than an audio cable. and I just don't like making them.
So it's something better. You could go off to your local shop and just buy it then. This is something you want to spend the money on.
You can spend the money on it. You don't have to buy a monster cable because SVHS actually sends its luminance information down 2 pins and its chrominance information down 2 other pins. That means that no matter how crummy your cable is, it's still going to be a really good signal, just as long as you get it as short as you possibly can. And then don't coil it up into big bundles. Let it run all the way down and let it run all the way back.
Okay. Now, how about something like, I have to admit, I did spend like $150 on a monster DVI cable. It was the only one in the store, and it was gold plated and all that good stuff, which we know is kind of, But is that something that you can build yourself? Not really. I mean, too many pins, too much of a pain.
It's too many pins, too much of a pain. It's definitely a machine practice. I mean, you really have to have an automated machine putting those together.
And that would be the same thing for like an HDMI as well, right?
Exactly. And quality of the cable. You don't have to buy a monster cable. In fact, if you go to places like eBay and stuff, you can get an HDMI cable, you can get a DVI cable, you can get HDMI to DVI cables, and you'll spend less than $10 for them. And there's no quality difference because it's a digital signal.
Right, exactly.
It's not as susceptible to interference or anything like that until you get long links. And we're talking anything over 20 feet. You start to notice that. We're talking our cables less than 5-6 feet here.
And then you feel the same way about obviously like optical cable and digital optical cables. I mean, we really don't see any need to go monster there, right?
Right. It's just light. It's just light, and light goes really far without any help or any impedance or anything like that. And I'll be honest with you, put together tons of professional bays, and they go and buy the cheapest cable they possibly can because they'll never know the difference.
Now, what about, say, speaker cable?
Well, this is the one time I really think Monster Cable did it right, and there's no way I can beat them. I mean, technically, it is an amazing wire. They do this. Basically, they have this really tight stranding that's almost at a 45-degree angle.
So you kind of notice that here, yeah.
And if you notice this, the banding that goes across it is at a really sharp angle. And that's what you really want, because the more banding you have, the more surface area of copper you have, and it's really great for your low basses. Now, here's the other great thing to do. If you go to a store, grab yourself a roll of Monster Cable, and then look at the stranding. And then walk down the aisle and look for a similar gauge cable and look at the stranding at that. You can see right through the jacket to find that.
Right.
And look for as close to a 45-degree angle as you can, and that's going to be really comparable.
Okay.
And if you were doing your place and you really wanted to be anal about it, use the Monster Cable for your subwoofer, and use one of the off brands for your surround speakers and your left and right and center channels.
Save yourself a little bit of money.
Save yourself some money even then.
Now, there's also higher grade cable than this Monster Cable here as far as, now do we need to go a step further to the even better cable, or is this pretty much where we want to stay?
This is pretty much where you want to stay. The only time that I would say you would want to go into those super high-end cables is if you're doing a central audio system in your house where you have 100, 200 feet speaker runs, and you've decided to put speakers all the way in the back end of your house and stuff like that. Then it's good to consider those if you want the best quality. However, most of the speakers that you mount into your wall have really crummy response, so you're not going to gain anything by it. So if you're going to put Monster Cables in your wall, make sure you get custom speakers made for your wall.
All right, sounds good. I think we finished pretty much everything here. Can you head over to Dan's house and help him out?
Yeah, I think I can give him some help over there and save him a lot of money.
All right, let's do it. Before we move on, we want to thank Jinx.com for supporting Systm. We've been wearing their shirts for years now.
So if you want to save 5%, head over to Jinx.com and use coupon code SYSTEM3.
Not only do they have great t-shirts, they have sweatshirts, hats, stickers, you name it, they got it. Head on over to Jinx.com, clothing for gamers, geeks, and hackers.
So Kevin and David showed you how to build your own cables. Now we're going to integrate those into my personal home theater system here. So David, what do we need to, what are the best signals to use, or the cables?
Right, the best cables to use are component and, for your analog signals, and HDMI for your digital signals.
Okay, why don't we just get this started, see what we can build.
Okay, well first we have to talk about a little bit of management down here.
Okay.
You'll notice that you have a receiver in this. This is where you're powering all your speakers from.
Okay, so we're talking component management here.
Right, we have to go through component before we get to cables. And you'll notice that you have all your speaker connections, and these speaker connections here are a big source of interference for all your audio and video signals, because there's a lot of wattage going on there. So if you put your receiver all the way at the bottom, you're going to get almost no crossover cables or audio crossing over the speaker cables and vice versa.
Right, okay.
So it's going to be really nice and clean coming off of it. And then we put the components on top of that, and then of course TV on the top. other things that you'll notice is that now that we're moving into the cable side of things, is that we need to think about power.
Okay.
Because we've got power cables, and thankfully, most of your components down here have all power on the right side.
Sure.
However, your TV's got power on the left side. And,
so what do we need to do?
Well, we need to get that cable over to the right side as fast as possible.
Okay, so you just string it over.
String it over perfectly straight, parallel. Don't try and do angles or anything like that. You want to have it perfectly straight. And then you're going to join it straight down.
Go down. Okay, down like this.
And you're going to join it with all the other cables in a really nice tight bundle and run that over to a power strip far off. Okay. And any excess from your power cords you just wrap up and leave over there.
Now I notice it looks like the power cable's on the right side and audio video's on the left side. Is that a coincidence or what?
Well, the manufacturers are really smart about this because they keep the power supplies over by the power cable, and then they put the audio and video on the circuitry on the other side.
Gotcha.
And if you open up one of these boxes, you'll notice usually a very large empty section of the chassis just to keep that distance as far apart as possible.
Sounds good.
And this is going to really help us with the cable management side of things. Because the next step we have to deal with is running all the audio and video. One of the things you'll notice about running audio and video is that a lot of people will very quickly want to go straight from here straight to there. You don't want to do that. We have to add a little bit of length in this case. And here's why. If I run cables at angles, they're going to eventually cross.
Okay.
And they're going to cross at this very shallow X usually.
I see.
And that makes a large bubble of interference right around that because it gradually builds up, hits towards the center, and then gradually dissipates.
Well, what's the best way to manage it then?
Run all your cables at 90-degree angles.
Okay, make them perpendicular to each other.
Exactly, because you're going to get this very small bubble.
So you pretty much, it's the lesser of two evils.
It's the lesser of two evils. Your cables are going to cross.
Right.
Let's work with it and try and make as a little impact as possible.
Okay.
In fact, in the professional world, they have these things called tie bars, which are put on the back of the racks so that the cables come straight out and go to these tie bars, and then that's what they use to keep everything at 90 degrees.
Okay, I see.
Which is really nice. And I mean, that's kind of how you're really going to organize everything and get all your cables moving around.
Well, I'm going to put you to work. Let's build some cables.
Okay, sounds good, but you know that I'm going to make you at least make one of them.
I'll try not to screw it up. So David has successfully managed to build every single cable in my home theater system.
Well, minus one.
Minus one, this one right here, I built myself, actually. We'll see if this actually works, by the way, though. So, okay, so what's the philosophy behind what you've just done? I see a lot of zip ties, a lot of cables, put together. What's going on?
Well, this is doing that cable management we talked about where we don't want to run any cable at a diagonal angle.
Right.
So we come straight off the back of the device, straight down, and straight along a large bundle, directly along the top here.
Okay.
Now you'll notice that what's happening is that anything that's going into it comes into it directly in line with that component's jacks.
Okay, and again, this is to minimize, interference.
Exactly. And you'll notice that it's not in the order of the components in the rack, it's in the order of where the connectors are on the component.
Right. And also what you've done is like, here's the power connectors right here, and they're all going down, straight line. But the thing is, like the television, the power connector is over here. You just strung it along and went straight down with the rest of the power connectors.
Exactly.
Okay, so what kind of how much time was involved with making all this?
It took me about 2 hours start to finish with all the cable management in there.
Okay, so how about for someone who's new to this?
I'd probably say about 3 hours if they have soldering experience, about 4 hours if they don't.
4 hours if they don't. Okay, so how about for the home theater enthusiast who kind of wants to take things a step further? What else can they do?
Well, the best thing they can do is get a power conditioner. That's one of the really good devices out there.
Right, like a power strip or...
A little bit different. Power strip is basically a distribution center. It just sends multiple power out, multiple power sources, has multiple plugs on it.
What is surge protector then?
Surge protector, all that's going to do is protect you against voltages when they go higher than 120.
But not necessarily lower.
Exactly.
Okay.
And a UPS is just going to protect you from going lower. A power conditioner does the protection against the high and the low, but it also helps filter out a lot of the interference that's coming down the power lines themselves.
I see. Okay. So how much does it cost to build all these cables for your home theater system then?
Well, we use really high-end connectors across the board, so we're looking at about $72 for all the connectors and all of the cables.
Okay.
If you don't have the tools, the total goes up a little bit. It's about $240, $250 for all the tools plus the cables.
Okay, let's throw in monster cables instead. How much is that going to cost?
Well, about $120 for this DVD player, $120 for this cable box, and about $60 for this receiver. So about $300.
Wow. Okay, so obviously it's better to build your own. Where can we buy these materials?
Well, probably the best place for you to go is marketech.com, and they carry all the cables, the connectors, the tools, all at one place.
I see. Okay, so let's turn everything around, fire it up, and see if these cables actually work, especially mine.
Yeah, I'm questionable about that one.
Okay, David, so obviously you can see the picture is beautiful, but if I screwed up somewhere in the cable making process, what would the picture look like?
Well, you start to see interference on the screen, or horizontal banding, or waves or speckles or something like that. But the biggest culprit is going to be bleeding.
Bleeding, okay.
You're going to see colors kind of bleed over into other colors. Red being by far the worst out of all.
Well, this is a perfect example. This scene is completely red.
Exactly, and red loves skin tone.
Yes.
So you would start to see the red kind of bleeding over into Jar Jar, Natalie Portman, or any of those areas.
Well, David, thank you so much for sharing your expertise with us. In the meantime, let's watch some Star Wars.
Cheers.
Cheers to that.
So there you have it, all the info you need to get started and save yourself a ton of money.
For all the links in David Randolph's article, head over to system.org.
I'm Kevin Rose.
I'm Dan Heward.
See you next time.